Hello, I'm Miles Thornton, and I'm going to talk today about the JavaScript engine upgrade that we have done as part of the Oasys Suite 18. For Oasys Suite 18, we have upgraded the JavaScript engine that's used in all of our programs. The JavaScript engine was originally added to the Oasys Suite roughly 10 years ago and supported the version of JavaScript that was available at the time, ECMAScript 5. However, the JavaScript language is constantly evolving and has changed significantly since then. In 2015, ECMAScript 6 was released, which was a major change. The engine that we use in the Oasys Suite software is SpiderMonkey from the Mozilla Firefox browser, and we now have upgraded the engine to the current extended support release version, ESR 78, which will enable you to use these newer ECMAScript 6 features. In the future, we will target the latest ESR version of SpiderMonkey for future releases of the suite. For the remainder of this talk, I'm going to discuss these changes. I'll briefly cover why we have upgraded the engine, give a few examples of the ECMAScript 6 features, discuss some other improvements from upgrading the engine, and talk about the other important changes you should be aware of. In the following slides, I will talk about Primer, as that is the most widely used JavaScript implementation in the Oasys Suite, but much of this also applies to the other programs D3Plot, THIS, and Reporter. As I mentioned on the previous slide, the main reason for upgrading the engine is to allow ECMAScript 6 features to be used in Primer. As the JavaScript engine we had in Primer 17 only supported ECMAScript 5, we were finding that people would try to write scripts using JavaScript knowledge they had picked up from tutorials on the internet or by reading a book, only to find that it would not work because it was an ES6 feature and we only supported ES5. Upgrading the engine allows these newer features to be used. As we have now upgraded to the latest extended support release from Firefox, ESR 78, you can get details of all the ES6 and newer features that are supported at the website that's shown here. I don't want to go into great detail about all of the new ES6 features that are now supported from the upgrade, but some of the main ones are shown on this slide. If you want to get more details, then please look online or get a good JavaScript book, such as JavaScript: The Definitive Guide from O'Reilly. It is worth illustrating a few changes though, so on the next slides I will give a couple of examples of how using new ES6 features could help. The first example is how to define classes in ECMAScript 6 compared to ECMAScript 5. ES6 provides a new class keyword to make defining classes much easier. So as an example, here we are defining a circle class, and the constructor for the class takes the radius of the circle as an argument. We then create an area method to calculate the area of the circle. On the left, we can see the syntax in ES5. On the right, the syntax in ES6. To be clear, this was all possible to do in ES5, but the ES6 features provide some syntactic sugar to make this easier to do and easier to read. One of the problems in ECMAScript 5 was that variables did not have block scope, and it could cause subtle problems. If a variable is defined using var in a function, it is scoped to the body of the containing function, and it is hoisted to the top of the function as if it were defined there, but the initialization of the variable remains in the same place. This means that the variable has the undefined value before this point and can be a source of bugs in code. If you declare the variable again later in the function in a block scope, the declaration will be ignored and it will just be the same variable. Using let instead of var in ES6 fixes this problem. By using let, variables now have block scope, and it is now an error to try to use a variable before it is defined, rather than a variable having the undefined value. Repeated declarations of a variable in the same scope is also an error. Note that, as shown in the example on the right, you can redeclare a variable with the same name in a nested scope, and it hides the variable from the outer scope, but I wouldn't recommend this. As well as adding support for ES6 features, there are also other advantages to upgrading the engine, and I'll now discuss a few of them. Firstly, the amount of memory that's required for garbage collection has been reduced in the new engine. Every time you create an object, array, or string in JavaScript, it has to allocate some memory and keep track of it. It does this automatically for you, and you do not need to do anything. And it does this by a process called garbage collection. This also uses a small amount of memory. From the test that we've done, with the default garbage collection memory size of 25 megabytes, Primer 17 could create roughly 350,000 objects before it ran out of memory. In comparison, Primer 18 can create roughly 500,000 objects before running out of memory. So the amount of memory required in Primer 18 is approximately 2/3 of the memory that's required for Primer 17. As well as less memory, another major advantage with the new engine is speed. From the test that we performed, many of the core JavaScript features such as maths operations, string manipulation, and regular expressions are significantly faster. Also, other things that use these features, such as reading files and extracting data, will also see some speedups. Note, however, that these speedups are for core JavaScript features, not for everything in Primer. So, for example, doing a model check in JavaScript will call the main Primer code to check the model, and this is not done in JavaScript, so that will not be 3 times faster. However, as many things can be done in JavaScript, these speedups should be significant. To enable the JavaScript debugger to work with the new engine, it's had to be significantly rewritten, as the tools to implement it have completely changed. This has enabled us to fix a few significant problems the debugger had in Primer 17. Firstly, for debugging large scripts, especially for scripts that had a lot of functions, stepping through the code using step and next in the debugger will now be significantly faster in Primer 18. Also, in Primer 17, if you tried to use try and catch blocks in a script to handle exceptions, these just did not work in the debugger. The catch block did not work and the exception would always be thrown. This now works properly in Primer 18. Another change in the debugger for Primer 18 is strict mode. Strict mode is a restricted variant of JavaScript to help try to stop some common errors in scripts. For more details, please use the link on the slide for more information. In Primer 18, the debugger now runs in strict mode by default. You can turn it off if required by using the checkbox in the debugger. Note that the checkbox still existed in Primer 17, but this didn't actually enforce strict mode. It actually just added a few extra checks when running the script in the debugger. It didn't enforce strict mode, so this behavior has actually now changed between Primer 17 and Primer 18. Upgrading the JavaScript engine in Primer 18 also gives better checking for scripts. As an example, in this script there are missing curly brackets in the if statement on line 8. So that means the return statement on line 10 is not part of the if block. It's a mistake. The return statement will always get executed, not just when the if statement is true. This means that the code on lines 12 to 17 will never get evaluated, as they are after the return statement. This mistake would be missed in the old engine, but the new engine now finds this problem. This better checking has already helped us find a few errors in our own scripts. I now want to spend the rest of the time discussing important changes due to the upgrade of the JavaScript engine. The first of these is how garbage collection memory is allocated when multiple scripts are running. This issue is specific to Primer, as that is currently the only program that can run scripts concurrently. In Primer 17, the garbage collection memory was private to each script. So, with a default memory of 25 megabytes, each script would have its own 25 megabytes of garbage collection memory. With the new engine, this has had to change because the implementation has changed. Now, the memory is shared between all the scripts that are running at the same time. If you only ever run one script at a time, then this change will have no effect. However, if you do run scripts concurrently, then this might mean that you have to increase the garbage collection memory size. When I was discussing the new ES6 features earlier, you might have noticed that one notable ES6 feature, modules, was missing. Upgrading the engine allows virtually all of the ES6 features to be used. Unfortunately, to allow modules to be used also requires significant changes to our implementation, as well as upgrading the engine, and we have not resolved the issues in time for the Oasys 18 release. However, we want all our users to benefit from the other ES6 features and benefits I have already discussed, so instead of delaying the upgrade until the Oasys 19 release to resolve the module implementation, we have released the new engine without module support in Oasys 18. We will add support for ES6 modules in a future release, Oasys 19. ECMAScript 6 has introduced a set class for collections. However, several years ago, we also defined a set class in Primer to allow access to the *set keyword in LS-DYNA. If we now change the name of this class to something else to allow set to be used for ES6, we could break lots of existing scripts. So, by default, set will continue to be used for our *set support and not the ES6 set class. If you do want to use the ES6 set, there is a preference which you can set to enable it. However, to allow the ES6 set class and the *set keyword class to coexist, the class that we have to support the *set keyword has been renamed to setK. Set is now an alias to setK unless the preference is set above. This means that if you look at what type of a class a *set keyword is, using instance of, it will return setK, not set. But everything should work as you expect. As the new JavaScript engine has extra error checks, such as the check for unreachable code we discussed earlier, in some rare cases, this may now mean that a script that worked in Primer 17 will now not compile and run in Primer 18 until that error is fixed. In Primer 17 and earlier, if a script was encrypted, then no error messages would be given if an error occurred or an exception was thrown when the script was running. The idea was that as the script was encrypted, the error messages would not be useful to anybody. However, more people are now encrypting scripts to release to their own teams or companies, and this could make it very hard to determine why a released script was failing. Because of this issue, and also the extra checks we mentioned previously, we've now changed this behavior, and error messages will now be given for encrypted scripts. Thank you very much for your attention. If you have any questions on this or anything else, please feel free to contact us for more information at any of the places below.